Hello everybody. So what this assignment is going to be basically a walkthrough for your first programming assignment. Okay, so what I'm going to talk about in this lecture is basically how you want to go about like getting the PDF and how do you want to write up your work and that kind of stuff. All that's just as important as actually writing the code, which I mean, it's pretty limited code at this point. You're still at the stage where you're learning what Matlab is about, basically. So the actual programming work is pretty easy. You're just mostly going to be thinking about, you know, how Matlab works and how I want you to write it up and turn it in. So let's go ahead and get started here. So if you look down here in week 2, it'll be in week 2 and in week 3. You'll see a new link that says Programming 1. So Programming 1 is a link to that first assignment. So if I click on that, it brings me here. And let me just actually edit this. Obviously you can't, but I have it wrong, so I'm going to fix it right now. Submit it online. I'm going to take file uploads, and I'm only going to take PDF files, M files, and zip files, and that's it. You can see I'm setting the allowed attempts to unlimited. That means that if you attach your files wrong, you can come back and fix them later. Okay, so this is your first assignment. So you'll see in the assignment here that there's a link to a PDF, which we'll look at, and then there's also a zip file. You're going to need that zip file. Well, you're probably going to need that zip file. So let's look at the PDF first. Okay. So I'm going to save it in a folder here, and I'm going to download the zip file, and I'm also going to save that to the same folder. You'll see it in a minute. Okay, so I saved those, the zip file and the PDF. So let's go over to my, oops, sorry about that, OBS. Here's the PDF. So this right here is what, this is your homework assignment, right? Like you would print this out maybe, and you would use this as your model for what you want to do. Now, if you look at this PDF, there's some couple things that you need to notice. So all programming assignments must include a PDF of your write-up, including results, Matlab code, and written answers to questions. And I say include the text of the problem you're answering. That's very important because if I don't do that, I get a lot of people where it's just like copy pasted nonsense in like a Word document or something. So I need to know what question you're trying to answer. I make that easy for you, and you'll see that in a second though. So let's see, all programming assignments will have at least one M file. M files are scripts or functions that you must also submit even if your code is included in the PDF already. Now this is important here. If I scroll down to a problem where you're writing code here, like look at problem 4 here. It says 5 points for your M file. So that's the code you write in a file. And then it says 5 points for copy pasting your code into the PDF. So that's the same code from the M file. I'm asking for the same information twice. The reason for that is if I want to run your code, I need the M file. So that's why you have to include the M file. But if I want to grade the assignment, I probably don't need to run your code because I can look at the code and see if it's correct. And that's why your code needs to be in the PDF. So that way I can just look at your code and make sure it's correct. Okay, so like this problem 4 here is 15 points total. 5 points for writing your code and putting it in an M file. 5 points for the same code here in the PDF. Well, your PDF, not my PDF. And then 5 points for including your results. Now results, sometimes you are asked to answer a question that your code was supposed to answer. and that's what's happening here. Some questions actually just ask you questions, and you need to answer that. Like right here, it says, create a script that adds up the cube of numbers 1 through 50. So 1 cubed, 2 cubed, 3 cubed, etc., all added together. And I say use a for loop, like I showed. And then I say, look, make sure you actually report the sum here in the PDF, right? Like, don't just write the code. Tell me the answer. What is this? When you add up all those numbers, what do you get? Okay, that needs to be in here, and that's the results that you need to include for 5 points. Okay. Other questions will just ask you, other problems will ask you questions, and you'll have to write out something in sentences. Like, let's see here, like problem 1. 5 points for the explanation of your results. So I say run these commands. Explain the differences you see, right? So you have to write something here, some kind of text, okay? So just make sure you do everything it asks you, otherwise you'll lose points. I'm not gonna send you emails to say, hey, you didn't actually do that. You know, you didn't do this for problem 1. I'm not gonna do that, right? I'm just gonna go, oh, it's missing, so you lost those 5 points or whatever, okay? Now, hopefully everything that's worth points is listed in the homework. You know, it says here, run Matlab commands requested. If the results are requested, copy, paste them in a readable format. I need to be able to read what you're typing. If it's a badly formatted mess, maybe I can't tell what you're trying to do. All right, what else? Answer any additional questions that the problem asks. Sure. And then I say LaTeX. That's probably a word you're unfamiliar with. So it looks like latex, but it's actually pronounced, the X is actually pronounced as a K. So it's LaTeX. LaTeX source for this file is up on Canvas. If you install a LaTeX system on your computer, you may be able to save some work on your homework. And that's the next thing I'm going to show you. Okay, so before we do any MATLAB code here, I want to show you what this LaTeX thing is all about. Okay, so let me go to that folder where I just saved the homework. Here it is. Okay, oops, that's not it. Why'd I open PD? Whoa, okay. Here it is. So in the programming assignment number 1 here, if I look in that zip file, I'll open it up so you can see. In this zip file, there are 3 files. There's a plot PNG file. That's just a plot that it's included in the PDF. There's a file with a TEX extension. That's a LaTeX source file. And then there's a file that says mcode.sty. And mcode is basically, it's basically a little function that tells LaTeX how to do MATLAB code. So like if I scroll down here, you see this right here, this block of MATLAB code. Notice that it's actually syntax highlighted the way that code is in MATLAB. And the reason it's formatted all pretty and included in a box is because that's what that mcode.sty file does. Okay, so there's 3 files in here. Now what I want to do is I want to open a thing called overleaf. I'm going to close this and then open it up again. So this is how I recommend that you do your homework. You don't have to. You can just type it up in Microsoft Word. But go to this site, overleaf.com. And when you first get there, you're not going to be logged in. So I'm going to log out real quick. So you come here and you just see this. Log into Overleaf. You have to log in, unfortunately. I saw somebody, it says like log in with your email. A student in one of my classes actually every single week made up a new login with a fake email address. Why did he do this? I don't know. But you can create an account. If you have like a Google account, you can just use that. That's what I do. So like if I click log in with Google, then I get all my files. And you see I use this a lot, like a lot, right? These are all things that I typed up in here. Now, I I know that you still don't know what's going on here. So if I go to new project, so see new project, I click new project. There's a few ways to do this. Blank, example, upload. I'm going to try upload, but I could also do a blank, but I'm going to try upload. So upload zipped project, select a zip, or drag a zip. So I'm just going to drag this programming assignment number 1 over here. Drop it in. Okay, and it says programming assignment 1-1. That's because I already had something called programming assignment 1. Now let me drag this slider over here and let's look at what we have here. So on the left hand side here, you have your 3 files. The mcode.sty, that's just included. The tech file, right, ends with tex, and then this plot. Now I'm going to click on this program homework number 1 tex. So what you've got is basically on the right hand side, this is your PDF or my PDF of the entire assignment here. Okay. So there's the PDF of the entire assignment. And in this middle panel, this is the source code for that PDF. And I know that it looks kind of monstrous, right? It's like a big mess, jumble of symbols and things. But if you go ahead and use this for your homework, you're actually able to do your write-up for the homework just by making small edits to this file. And it's really, really simple to do. So like, notice that over here on programming assignment 1, notice right above that, it says name here, right? Well, I can just start editing this file into my work if I was a student, right? So let's say I'm a student. So what you do is, it's hard to read, but there's lots of stuff you ignore, right? Like ignore all of this source codey looking stuff that you don't need. It says begin document somewhere. Below that it says name. You can find that where it says name, and that's this name. So like I would be able to, if I was going to edit this PDF, I can just come here and I can type in, my name is Greg Hogan. So I type that in, and after I type it in, then here it says recompile. Click it. Wait. There's my name, right? So if you did that, now you would have your name on this programming assignment. Okay? So now let's leave this alone. Let's edit this. September. Fix typos. Fix all my typos. It's required, by the way. All right. So here we go. So this is the PDF, right? And so like, let's say we want to do this first problem here. Open Matlab and run the following commands at the prompt. Okay, here's some commands. Now, let's actually do that. So where's Matlab? I have Matlab running. So let me just, whoa. Okay. Actually, I want that like that, and then I want this like this. Okay. So I'm doing this in Matlab, but you can use Octave, right? It doesn't matter. And that. Okay. So what am I running? I'm running t equals 1:3. What's that do? It makes 1, 2, 3. That's a vector. 1, 2, 3. All right. What's the next one do? W equals colons 1, 2, 3. Okay, that does the same thing, right? So I'm just showing you more than one way to do the same thing here. T 1, 2, 3, W 1, 2, 3. The next one says x equals 1 semicolon 2 semicolon 3. Oh, that's different, right? So that command is different. It made a column with the numbers instead of a row. So that made a column. So semicolons made a column. Right? All right, what's y do? Y 1, comma 2, comma 3. What's that do? Oh, it made a row again. Okay, what's z equals 1, 2, 3? That's spaces, just like the W was spaces. But then there's an apostrophe on the end. What's that do? Makes a colon again, right? Or sorry, makes a column, not a colon. If you take off the apostrophe, it's a row. You put an apostrophe, it's a column. All right, so just based on what we did here, I just said explain the differences you see in the results. Okay, let's explain the differences I see in the results. So two of these, like they all made vectors, 1, 2, 3. Two of them made column vectors and the others were rows. That was the differences. So let's go back here. How am I going to get that answer in this PDF? Well, what I can do is I can, in this, oops, hey, come on, let me drag this, okay. If we scroll down, you'll be able to find problem 1. It's a little, you have to kind of learn to ignore the source code-y stuff, but if I keep scrolling down, I can find the t equals 1, 2, 3. I can find this block of code here, right? I find it right here. Notice, by the way it says begin list, LST, and then listing. So that's like listing. That's how I read it. I don't know. And then in between it, I have those commands. Well, this begin list listing and end list listing is what tells LaTeX here to put the inside into a box and format it like Matlab code. So you'll see those all throughout the problems here. And then below that, you see explain the differences you see in the results. So you can just type them here, right? I can just type them. I can say all commands made a vector 1, 2, 3, but well, which ones were which? So some were row vectors. That's what we'll call the ones that are rows. Which ones were rows? T was a row, W was a row, Y was a row, and some were column vectors. Which one were column vectors? The one with the semicolons, that was X, and the one with the apostrophe, that was Z. So like I can just type this answer in here, hit recompile, right? And now I'm done with problem 1. And if I decide I don't actually want this, I can do something like this too. I can go like answer, just to make it obvious that that's the answer. Right, there you go. I'm done with problem 1. Right, that's it. And so do you see why I'm advocating that you use this method for typing up your homework? I'm advocating it because then you don't have to open Microsoft Word and start copy pasting a million things into it. And how are you going to format the Matlab code and make it look nice? None of that stuff is stuff you'll have to worry about if you start with my document that I give you. So, all right. Let's see. Let's move on to the next question here. So after this point, you're going to have to start making some M files and getting used to how MATLAB files work. That's weird. So what are we doing? Problem number 2. 5 points for the M file. Okay, so problem 2, we're just making an M file. What does it say? Create a new script, text file with a .m extension called an M file, and copy paste the following code. Call the M file prob2.m. So problem2.m. How do you do that? Well, it depends on if you're using Octave or MATLAB. So let's see. Here's MATLAB, and Octave is here. So I've got them both open side by side. So remember how to do this. It's slightly different depending on which one you're using. So if I'm in MATLAB, the way I would create a new file is I would have to, I think, click Home, because it's on apps for some reason. Click home, and then I can click new script. There's my script. And then if I want to save it, what do I have to do? Let's copy paste the code. Now, one thing I want to be I need to be clear about, like, let's say I want to try to get this code into that IM file, and so like I want to select it, copy it, and then Matlab, paste it. Copy pasting from a PDF often does not work. You'll get mistakes. Like it's even telling me, like, see how it says, like if I click on it, it says invalid character. That's because it looks like the right symbol and it's not. Okay, so be very careful. Don't copy paste from the PDF the way that I just did. It's bad. If you want to copy paste from this. This is regular text. So like if I come here and I copy paste, copy that, and Matlab, paste, no errors. Now, look at that symbol there, the little caret symbol between the X and the 2. Let me go back and I want you to see something. There's a little red caret. Now, if I paste, it's a different caret, right? There's actually, in like the font, there's multiple symbols that look alike, and the PDF used one symbol, but it's not the symbol that's on your keyboard. And that's why you can't just copy paste from PDFs into Matlab and have it work. Okay, so anyway, so I just did that, and then if I want to save it, there's a few ways to do that. I can click save. That's obviously the easiest way. And then it prompts me for the file name. So I'm supposed to save it problem2. So I'm actually going to call it problem2 matlab.in. Okay. So I saved it. All right, that's fine. Now, how would you do it in Octave? Well, just about the same way, except that there's no new script button. So like you can click File, New Script, like that. It, again, gives me a text editor. I can paste again. After I paste it, I go to this file, not the one way over here, the one on the editor, and go to Save File. And again, I can save it however I want. So I call it prob2, maybe I'll call it octave.m. Save. Okay, so there you go. I've got it saved twice now. And if I'm in Octave, the way I get back to the command prompt is look down here. It says editor, that's the editor, command window, editor, command window, editor. Yeah, all right. So there you go. So that's how you save these files. Now, what are we doing now? So it tells me the linspace command creates a vector that starts at A, ends at B, and has n equally spaced entries. Now you can experiment with that and see what it does. So like in the command prompt here, I'm going to type it linspace. So like if I do this, if I go 1, 3, 3. Starts at 1, goes to 3, the vector has 3 things in it. And if I go 1, 3, 6, starts at 1, goes to 3, has 6 entries, right? So now they go 1, 1.4, 1.8, 2.2, 2.6, 3. They still start at 1 and they still end at 3. But now there's 6 things in there. And that's what linspace does. So like if I go 1,000, then I get a vector with 1,000 things in it right here on my screen where I want it. Ugh. And what's it say? Well, let's go back here, right? So they start at 1 and then 1.002, 004, 006, right? It's counting up from 1 all the way up to 3. And the spacing is whatever the spacing needs to be in order to get 1,000 entries. Okay, so I think we talked about that in the last one. But so this right here goes -2 up to 2, and then there's 5 things in it. And if I try to run this, we get an error, right? So the x part worked, right? X equals linspace -2 to 2, comma 5. So I did get the vector -2 to 2 with 5 things in it. And then I got an error message, and it tells me what's wrong. Incorrect dimensions for raising a matrix to a power. Check the matrix is square and the power is a scalar. To perform element-wise matrix powers, use dot caret. Okay, and the PDF explains what they're talking about here. It says it's trying to use matrix math, and matrix math is not allowed, basically. So let's go look at it here where it's bigger. So what you have to do is, if you want it to actually, what I wanted this code to do was go -2 squared, which would have been 4, right? And then I wanted to square every term is what I wanted to do. So if I look at this, right, I wanted to take -2 squared and get 4, -1 squared and get 1, 0 squared and get 0, 1 squared and get 1, 2 squared and get 4, right? So what I wanted was the vector 4, 1, 0, 1, 4. I wanted to square all of these. That's what I was trying to do, and I failed. And the reason I failed is because you don't just use the caret for a second power. You need element-wise power. And so it tells me, well, I tell you right here, you need to change the caret to a period and then a caret. So if I come here, that's what you need to do. Fix it, save it, have to save it, and then I run it. I can run it a lot of different ways. I can type problem to Matlab, or I can click the run button. I'll click run. Now it worked. X, Y. So it actually did square. -2 squared is 4, -1 squared is 1, 0 is 0, 1, 1, 2, 4. Also, I actually said I was supposed to go -3, 3, and 7 in that second script. So let's do that. Let's do it in octave here. So if I do it in octave, the second script was supposed to be 3, 3, 7, and a dot caret. So I can go, this is the run button here. It doesn't say run. Save file and run. Click it. Command window, and there's the results. Right? So I squared all of the x values. All right, great. That's all I needed to do there. So yeah, so that's all I needed to do. So I go through and I just do all of my homework problems this way. There's some stuff where you have to explain what's going on. Like there's some loopy stuff here. Supposed to put all this into a script. So like problem 3 says 5 points for M file, 5 points for explanation. So again, we're supposed to be putting this into an M file called problem 3. So again, how am I going to do that? Probably if I want to copy paste because I'm lazy, I should find this code in this file. So I scroll down, I eventually find it just by matching the text, right? Like first loop, example for loop. First loop, example for loop. So this is the code for problem 3. So copy it. Can I, hold on, let me reset the windows. Okay. Whoa. All right. So if I want to create problem 3, how could I do it? Well, this is still a script, so I right click. No, right click doesn't work. So I go File, New Script again, paste my code. File, oops, not that file, right? This file, File, Save. What do I call it? prob3.m. Save. Now it's saved. And then there you go. I got my code here. So I'm supposed to run it. Now, if I don't want to click the run button, what I can do is I can actually type in the name of the script. So in the command window, I can type prob3. That will run the script. Okay, so you see that this script actually prints some text. And what this script is supposed to be doing is showing you the syntax for a for loop and for a while loop and for an if statement, which is maybe too much to happen all at once, but that's what's going on here. So like, let's take a look at this first. For loop. So the way a for loop looks is it goes like for I equals 1 to 5, right? So that's going to go like I equals 1, then I equals 2, I equals 3, I equals 4, I equals 5, and then it's done, right? So it's going to loop through 5 times, and every time through the loop, I is going to have a different value. So it just goes through this loop 5 times, 1, 2, 3, 4, 5. And then every time you're in the loop, it's going to use a printf command. Now, I used printf here. It's not the only way to display text in Matlab, but I'm using printf because you all should have taken a Java class, and I think that Java has a printf command too that looks a lot like this. Most programming languages do. So like Python has one that looks a lot like this. C++ and C have one that looks just like this. I think Java does too, right? So, so this is just a normal printf command that looks a lot like what you do in Java. So what's the structure of this one? So the text we want to display is in quotes. The current value of I is, and then it has a %d. Hopefully you remember how this works. So the %d is a placeholder. So a number is going to get inserted in the text where that %d is. What number is going to get inserted? I, right? So the number, whatever the value of I is going to go where that %d is. Okay, so if we look at the command window, we can see where it ran the code right here, right? Current value of I is 1, then 2, then 3, then 4, then 5, right? 5 times through the loop, and I went 1, 2, 3, 4, 5. The \n, that's the new line character. That's what tells Matlab to go to a different line. So like if I take that line off and then I run problem 3 again, you'll see why you need a new line. See, if you don't tell it to go to a new line, it just keeps writing all the text on the same line. And so \n means new line. It means drop it down to the next line. So if I do like this, for example, oops, not like that. If I do like this, \n, there should be some blank lines when I run that. See, like so. So every \n means skip to the next line. Okay. So the way for loops work, well, you can see how to do a for loop if you know how many times you want to go around. Every for has to be ended with an end. Now in Octave, you could also end it like this. End for, so that you know you're ending a for loop, but I'll show you a problem with that. So let me save this, run the code again, runs perfectly fine. Now let's go to Matlab. So here's Matlab, and I could run prob3 in Matlab, prob3. What's it say? At least one end is missing. The statement may begin here. So here's prob3. So open up prob3, here it is, and same code, but it does not understand end for. Only end. So if I change it back to an end the way I had it originally and type prob3, undefined function printf. Oh, Matlab doesn't have printf? Yes, it does. Hold on. I know it does. You kidding me? Really? Okay. I really have to call it this? That makes me sad. Wait, no, that's not right. Huh. Okay, well, good to find it out now. I think this will work. Hold on. Yeah. So this is dumb, but I think this will fix it. Okay, try that. Okay, now it works. That's really dumb. I had no idea that Matlab did not support printf. Everything has printf. Okay, but it has sprintf. All right. Now here's the question. Does this work in Octave? Let's look. Display sprintf. Think that runs? Let's find out. Yeah, it runs fine. Okay, that's not the ideal way to do that, but that'll work for now. So what sprintf is that means string printf. So what's happening is this inside block is creating a string, and then display is displaying it. Now, why can't I just use printf then? I don't know. But it is what it is. So we will continue on here. All right. So that's how the for loop worked. A while loop is very similar, right? But you all are supposed to know how a while loop works. So a while loop loops through while this condition is true. So this is going to loop through while j is less than or equal to 10. So j is starting out 0. While j is less than or equal to 10, do something, okay? And so this while loop ends down here. Now, everything else in here is inside of the while loop. So what's it doing? Well, it's not going to do anything unless j is 7, because it goes if j equals 7. So if j is equal to 7, then we're printing something on the screen. And otherwise, well, not otherwise, after we print something on the screen, we're just adding 1 to j. J equals j plus 1. So it's just looping 0 through 9, no, 0 through 10, and it doesn't do anything at all except print a message on the screen when j is 7. All right, now I changed it to that display sprintf thing. What to do, it says, looks like j is 7. J equals %d. Remember, %d is a placeholder. It's going to actually print j there. And only does this if you're inside, if j is 7, then you do this, otherwise no. Okay, so you're, again, stuff you should be familiar with from Java. Okay, the only new thing is syntax. Like, you don't need parentheses around this. You can have parentheses around this, but it's unnecessary. Same thing with the if statement. You can have parentheses, unnecessary. Semicolon, you could even take the semicolon off, but we don't take the semicolon off because if we do, it's going to print this on the screen every time. See? That's probably not what we wanted, to see that on the screen every time. So you use semicolons when you don't want to see it on the screen every time. Just, we only wanted to see our specific display commands on the screen and nothing else. Okay, so we created a script. All right, I'm not going to do the next problem. I do want to say something about functions because we did not talk about them in the previous lecture. So how do functions work? So a function is like a script. It's in an im file, so you still need an im file for it. But there's a specific structure to a function. It goes inside of the file. It says function. You list your variables, output variables, equals, you list your function name, and then in parentheses, you list your variables. And then inside, you just put everything that needs to happen inside of your function. And every variable in here is going to be a local variable. So here's a very simple function, which I called cubulator. Actually, let's copy paste it from here. As always, let's find cubulator. Here it is. Copy it. New, we'll do it in Matlab. There we go. Probably should end. Save. Now, this is very important. So, this file is called cubulator.m. This name here, cubulator.m, needs to match this name. If those don't match, your function has an error in it, okay? So the name of the file and the name of the function must be equal to each other. Otherwise, Matlab wouldn't be able to find it. Because, like, what if the file name was something different? Well, how would Matlab know that cubulator function was in a different file name, right? What if cubulator was in problem 3.m? Well, Matlab wouldn't even know about it, right? It wouldn't know that there was a function called cubulator. So those must match, file name, function name. Now, what's this say? Y is the output, X is the input. Here's the function. So if I run this now, cube u later, what's it gonna do? It's just gonna cube my function, right? It just did 4 cubed, that's all it did. 4 cubed, 64, right? Cubulator, -2. Answer -8, right? So all this does is it's just a simple cubing function. What you need to notice is I don't use the word return, right? No word return, you don't need to. You return the y variable, so you just need to make sure y has a number in it. So the return variable is y, there it is. The input variable is x, there's where I use it. Name of the function's cubulator, and then I can just down here run cubulator with any number I want in there. And in fact, because I was smart, I used .caret, and that means I can actually do something like this. Like a is 1, 2, 3, and then I can do cubulator a, and it will actually cube all of those. You have to make sure that you do use the .caret exponent, because if I take away the dot, this still works, right? I can still cube one number, but if I try to cube 3 numbers, I get that error that we got way earlier, where you can't cube a vector. You can only cube individual numbers. And the way you tell it to do the individual numbers one by one is with the .caret. Save. And then now the same command runs. All right, so that's how you make a function. Very easy, right? You just, anything you need to happen in the function, you put between the function start and the function end. The end. Save that. Okay, so what are you going to do? Nothing, right? It just, what file name do I need to save the function with? What result do I get? Why is it okay to call cubulator A even though up here it's called X? And the reason that it is okay is because X is a local variable to the function. It doesn't have to have any relation to what is called outside of the function at the command prompt. Right? That's how local variables work. All right, Next one, you're going to be writing your own function. You need to write this function. Not hard to do, you can do that. And finally, last thing in the homework is you need to make a plot. And so this function right here this code here will explain to you basically how to make a function and plot it and get a pretty graph, which I think we did actually talk about in the previous Matlab lecture, so I'm not going to talk about it too much. I'm going to scroll down to it here, find the code. Here's the code. Copy all of it. Let's do this in Octave. New file, paste, save. Me do plot now .m. It's not what you're supposed to call it. Hit run. Should run. There's my pretty file, or there's my pretty picture. And in the test plot here, I can open it outside Matlab, and it is just a nice PNG version of that plot. Okay, now once you have that plot though, you need to get that plot into LaTeX, right? So let me change the file name here. Let me just come down here and say plot. This is new plot. Let's do all lowercase instead of weird syntax here. All right. Okay, so I just ran that again. It made a new PNG file here. Now, how do you get that PNG file in here? Well, there's two steps. What you got to do first of all is you need to get the file in here. So you need to go navigate to the folder where that is. So here's this folder where I was doing all my work in. This is newplot.png. I don't think you can just drag it. No, you can't. What you have to do is you have to click this button here where it says upload. Then you can drag the PNG over, or you could have selected it on a menu. Now it's here. Okay, now how do you get it to show up? Well, the way you get it to show up is, I say, if you're using LaTeX like I'm using, you need a line that looks like this. Include graphics. The width is just how big to plot it, and then the name of the file. So there's already one in here, right? Because I have, that's what plots. We already have a PNG plotted, right? So if I want to plot an image down here at the bottom, I just need to find that line, put another one down here, note it before the end of the document, otherwise it won't show up. And let's say I want it big, 5.5 inches, and then the test plot needs to be this one. So I can start typing it and actually pick it off a list. There you go. And you can see the syntax for it. Hit recompile, and if I did it right, I should get an image right here. There it is. And so that's how you get nice images in your PDF. You need them first here, which you do with upload, and you could click on select from your computer and navigate to the file yourself, or you can drag it. Once it's in here, you just need an appropriate line to include it, and that's it. So yeah, that's pretty much your homework. You have until September 11th to finish that. I'm going to fix a couple of typos here. I'm going to change these printf lines, right, that we have to change to make them work in Matlab. And yeah, good luck. Come to office hours if you have questions, and I will be happy to help you finish your assignment. Friday is going to kind of be the day that we do Matlab, but you can come on any day. All right, so that is it for now. Talk to you guys later.